So this is a little bit of, well, an entire page of questions from 2.3 in your textbook, page 71. And I'm just going to pick out a few here and there to do, okay? So remembering all the divisibility tests that we've gone through, you should write them in your data book, so you can refer to them as you're doing these questions. So where should we start? 5s, 10s, pretty easy, okay? So let's look at number 3. And is 124 divisible by 5 or 10? No, because it doesn't end in a 5 or a 0. Is it divisible by 10? No, because it doesn't end in a 0. Okay, let's see, which of the following numbers are divisible by 4? Let's have a look at this. So if you flip back, you'll remember that a number is divisible by 4 if the last 2 digits are divisible by 4. So this is question 5F. And 8, 7, 6, 5, 4. Is that divisible by 4? Let's look at the number 54. Is 54, can 54 be divided by 4? No, it can't. So this number is not divisible by 4. Let's have a look at D. 8,764. Is that divisible by 4? So we'll look at, is 64 divisible by 4? And I'm kind of doing short division in my head, but 6 goes into 4 once, with 2 remainder, and 6 goes into 24 6 times. So it is divisible, the big number is divisible by 4. Okay, let's try what number is divisible by 8. Okay, so a number is divisible by 8 if the last 3 digits are divisible by 8, so that's actually the entire number. So in number 7b, 522. In order to work this out, you actually just need to do the short division, okay, to find out if it's divisible by 8. So 8, 522, 4 times 8 is 50, so 2 remainders, whoops, that should be a 2. 8 into 22 is not even, okay? So no, this number is not divisible by 8. How about, here's a great one. Find out if this number is divisible by 7. Use short division, because remember, there is no trick. So 9e, 48,993. Is it divisible? So we'll just have to do the short division. Sorry, I've just messed this up. Okay, so 48,993. 7 into 48. Well, I know 7 times 7 is 49, so it must be 6. 7 times 6 is 42, so I've got 6 left over. 7 into 69 is 9. And that's 63, so 6 remainder. And again, 7 into 69 is 9, which is 63, with 6 remainder. And then 7 into 63 is 9. So this number, yes, is divisible by 7, and it goes in 6,999 times. All right, moving right along. Which of the following numbers are divisible by 3? Let's try number 11. 3, but not 9. Okay, let's try this one. So number 11. 7 million. Oops, sorry. 564,896. Now, it's divisible by 3 if the sum of the digits is divisible by 3. So let's add that up. 7 plus 5 plus 6 plus 4 plus 8 plus 9 plus 6. All right, so let me do this. 6 and 4 is 10. And it's not going together as easy as the last one, is it? I know that 7 and 8 is 15, plus 10 is 25, plus another 5 is 30, then 39, and 39 plus 6 is 45, and is 45 divisible by 3? Oh boy, well, using short division, 3 goes into 4 once with one remainder. 3 goes into 15 5 times. So this number is divisible by 3. Now, is this number divisible by 9? Remember, the test is, does the sum of the digits, is that divisible by 9? So is 45 divisible by 9? I happen to know my 9 times tables, and this answer is 5. So yes, this number is divisible by 9 and 3. Okay, so for number 11, you'd actually have to keep checking all these other numbers to see if the sum of the digits is divisible by 9, by 3, but not by 9. Now, I'm going to do one more question. I'll move all of this up. These ones get a little bit tricky. So number 13 says, fill in the missing digit to make the following numbers divisible by the given number. State all the possible answers. Okay, so let's say we want to do part B here. Okay, so 13B. So we want to make 1, 2, 4, 5, 6 blank divisible by 6. So if we go look at our divisibility rules for 6, the number has to be divisible by 2 and divisible by 3. Okay, so first of all, we know that it has to end in an even number. Okay, and then it will be divisible by 2. And if it's divisible by 3, then the sum of the digits have to be divisible by 3. So I think we should start by writing down all of our possibilities. So 1, 2, 4, 5, 6, 0, 1, 2, 4, 5, 6, 1, 1, 2, 4, 5, 6, 2, 1, 2, 4, 5, 6, 3, 4, 5, 6, 4, 5, 6, 7, 4, 5, 6, 8, and finally 124,569. Okay, so which of these numbers is, actually, I got a better idea. So we'll have a column for 2 and 3. Okay, this is how you could be doing your questions in the book, in your questions book. So is this number divisible by 2? This one is, this one is, this one is, this one is, this one is. Okay, that's easy. We've just looked at the last digit. Now we have to find out if they're divisible by 3. Okay, so to be divisible by 3, again, the sum of the digits have to be divisible by 3. So let's do 1 plus 2 is 3, plus 5 plus, I like doing this another way actually. 6 plus 4 is 10, plus 5 is 15, plus 3 is 18. So these digits add up to 18. And is 18 divisible by 3? It sure is. Took me a while, a bit rusty. Okay, so yes, that number is divisible by 3. Okay, now that we've done the sum for this one, the sum of the digits for this one is 18. So here this will be 19, 20, 21, 22, 23, 24, 25, 26, 27, because we're just going up by 1 each time. Okay, so these digits add up to 19, 20, 21, 22, 23, 24, 25, 26, 27, and we could just do a double check if we wanted, okay? 5 and 9 is 15, plus another 5 is 20, plus another 6 is 26, and 27. Okay, so which of these numbers is divisible by 3? Well, we know 18 is, 21 is, 24 is, and 27 is. Okay, so the question is, which of these numbers is divisible by 6? And so they have to be divisible by both 2 and 3. Okay, so we have a look up here, the ones that are divisible by 2 and 3, this one and this one. So list all the possible answers, it says. 124,560, 124,566. Those are the only two possibilities that would be divisible by 6.